Starting with Dobrynin's law of traits, we have that when we are going to find the average mass of the first and the third element, we will be getting the mass value of the middle element. Okay, so that is Dobrynin's law of traits. For example, let us take this as trade 1, lithium, sodium, potassium. I am adding lithium's mass number with potassium's mass number. I will get sodium's mass number. Same like that, we have another trade pair, calcium, strontium, barium. Okay, so we have to find the average of first and third element, so we will get the mass number of the middle element. So next triad, chlorine, bromine, iodine. Totally we have 3 triads with 3 elements each. Okay, the limitation were that Dobrynin, he could only identify 3 triad, which is he could only identify 11 element with this kind of property. Okay, so later discovered elements, they were not going well with this particular law. Okay, so that is the main limitation that we can face in Dobrynin's law of traits. Now coming to Newland's law of octaves, it is nothing but do re ma fa sol la ti is a western musical note, and this Newland, he has arranged the elements in a western musical note in an arranging mass number order. As you can see, hydrogen, lithium, beryllium, boron, carbon, nitrogen, like that, whereas he did not give place for noble gases here. So as we can see, he concluded that the property of the first and the eighth element are the same. When you take H and F, hydrogen and fluorine, they have the same property. Lithium and sodium, they have the same property. So like that, what he took is that first and eighth element have the same property. But he also had some limitations. Talking about limitations, we have that he had discovered only 56 elements, and in that 56 elements, up to calcium only the law was working good. After calcium, it did not work well. And then we can also see that 2 elements are placed in one slot, like cobalt and nickel, okay, which is not correct. And he was also only able to discover 56 elements at that time known. Okay, so later discovered elements, they were having trouble in fitting with this particular table of Newland's law of octaves. So these are the basic limitations that we find in this table. Then Mendel introduced a periodic table with a periodic law. So he said that the physical and chemical properties of the elements are the periodic function of their atomic mass. So this is Mendeleev's periodic law. Okay, so he formulated a Mendeleev's periodic table. Okay, so as we can see, he left vacant places in his table, which is an advantage for future discovered elements. He gave it as Eka boron, Eka aluminum and Eka silicon, and also he predicted the properties of undiscovered elements, okay, on the basis of their position. Okay, and it is useful in correcting the doubtful atomic mass, and noble gases it was not able to accommodate in this Mendeleev's periodic table, which is again a drawback. So you can take a look, this is the Mendeleev's periodic table. So now we come to modern periodic table by Henry Moseley. I hope now what we are studying now is modern periodic table, and I hope everybody know about this. The left side we have metals, and the right side we have non-metals. So we can see alkali metals on the left side, the blue it is alkali earth metals. We have transition metals in the middle part. On the right hand side we have the noble gases, the extreme right we have noble gases, the right we have non-metals, and the pink one is metalloid. Okay, so this is about the modern periodic table. So now coming to the atomic radii, this is a trend in valency and everything. So atomic radii will decrease while we move in a period. Period is basically the horizontal line and group is the vertical line. So on moving from left to right, atomic size will decrease, top to bottom it will increase. Then ionization, while moving from left to right, we saw that the atomic size will decrease so that the force will increase. Okay, if atomic size is decreasing, the force will increase. Okay, if the force is decreasing, atomic size will increase. Okay, so that's it about the ionization. Now metallic character, in the left side, in the extreme left it is fully metallic, and then the non-metals are in the non-metallic character in the extreme right. And we saw a zigzag line called metalloids. It is separating the metals and the non-metals. So that's it about today's video. I hope you liked the video. Thank you for watching. Bye bye.